In this module, we are going to talk about fundamental theorem of arithmetic. Theorem of arithmetic. It says that every composite number can be expressed as product of prime numbers and this factorization is unique. What may change is only the order in which you represent the factors. Let's take an example. Let us take a number 12,600. If you do prime factorization of this number 12,600 divided by 2, so this is 6300 again by 2, so 3150 again by 2, again by 2, 1575, now by 3 divided by 3 means this is 525 again by 3, 51, so this is 175. Now this one will go with the 5, so 35 again with 5. So the prime factors of 12,600 are 2 cube into 3 square into 5 square into 7. That means when you factorize, when you represent 12,600 as the product of prime numbers, then you will always have 3 2s, 2 3s, 2 5s and 1 7. So you may represent 7 first, 2 in the last. So the order in which you represent can change, but the prime factors, that is 3 times 2, 2 times 3, 2 times 5 and 1 times 7 does not change at all. This is what the fundamental theorem of arithmetic states. Some of the observations here. Now, if any composite number is factorized, no, not any component, any composite number ending with 0, ending with 0 is factorized into prime factors, then its factors will have at least 1 2 and 1 5. If any number ending with 0, it will have at least 1 2 as the factor and 1 5 as the factor. Let us try one. 90 is ending with 0, divide by 2, so it is 45. Now divide by 3, so it is 15, divide by 3 again, it's 5. So you have 90 as 2 into 3 into 3 into 5. So you have 1 2 and 1 5. So if any number ending with 0, and if you find out the prime factors of that number that will have at least 1, 2 and 1, 5. This will help in solving some problems like let us take 6 to the power n. Now what the question here is there any value of n for which the number will end with 0? Is there any value of n for which, if you simplify the number, that end with 0? Just looking at it, you may not be able to say. Now let us use this principle. That is, any number ending with 0 must have a factor 2 and 5. We can solve this. So 6 to the power n can be written as 2 into 3 whole to the power n. That is 2 to the power n into 3 to the power n. So now this does not have factor 5 at all. So 6 to the power n cannot end with 0 for any n. For any value of n, it cannot end with 0. Now, fundamental theorem of arithmetic can be used for finding out HCF and LCM of 2 or more numbers. Let us look into that here. You must have studied this one in the previous classes also, but still, let us take 3 numbers. So 24, 36 and 40. Let us find out the prime factors of each of this number. 24 divided by 2 is 12, 2, 6, 2, 3. So 24 can be expressed as product of prime factors, that is 2 cube 2 to the power 3 into 3. Now let us take 36. 36 divided by 2, 18 divided by 2, 9 divided by 3, 3. So 36 can be expressed as 2 to the power 2 into 3 to the power 2. 3 to the power 2. So now 40. 40 divided by 2, 20 divided by 2, 10 divided by 2, 5. So 40 can be expressed as 2 to the power 3 into 5. Now you have now the prime factors for all these 3 numbers. How to find out HCF and LCM? Now HCF of these 3 numbers. HCF is the product of smallest powers. Each factor, each prime factor. The product of the smallest power. So what is the smallest power of prime factor 2? It is 2 square into, now here you have 3, here you have 3 square, here you don't have 3 at all. So it is the smallest power, you can say 3 to the power 0, that is into 1. Same thing 5. 5 is not there in the other 2. The smallest power is 5 to the power 0, that is 1. So HCF of these three numbers is 4. Now LCM. How to find out the LCM? That is the product of largest powers of each prime factor. So what are the largest powers here? For 2, it is 2 cube into 3, it is 3 square Then for 5 you have 5. So now if you multiply these things, 2 cube that is 8 into 9 into 5, 8 5s are 40, so this is 360. So LCM of these three numbers is 360. Now let us take two numbers 54 and 81. Let us do the prime factorization first and then find out HCF and LCM. So 54, the prime factors are 2, 27, 3, 9, 3, 3. For 81, 3, 27, 3, 9, 3, 3. So prime factors are of 54 are 2 into 3 cube, and for 81 it is 3 to the power 4. So the HCF is the product of the smallest powers of the prime factors. Here 3 to the power 3, here 3 to the power 4, so that is 3 to the power 3. Here it is 2 to the power 1, here you can take it as 2 to the power 0, so it is 1 only, so it is 3 to the power 3, so this is 27. Now LCM is the product of the largest powers of each prime factor. So that is, here is 2, here nothing is there, so it is 2, here is 2 cube, here 3 to the power 4, so it is 3 to the power 4. Now if you simplify this one comes to, LCM comes to 162, that is 3 to the power 4 is 81 into 2 is 162. Now product of the numbers is equal to product of HCF and LCM. Any two numbers if you multiply that is equal to the product of HCF and LCM. Suppose you have numbers A and B. A into B is equal to HCF of A comma B into LCM of A comma B. You can verify this. Now suppose if you multiply 54 into 81 you get 4374. Same way here, if you multiply 162 into 27, again you get 4374. So in this case there are four numbers, that is A, B, HCF of A and B, and LCM of A and B. If you know any three numbers, the fourth one you can find out. Now let us solve some problems. HCF of two numbers is 23 and LCM is 1449. If one of the numbers is 161, find out the other numbers. We know if the numbers are A and B, then A into B is HCF of A comma B into LCM of A comma B. Now we don't know we know only one number, so let us say we don't know A, so A into B is 161 is equal to HCF is 23 into LCM is 1449. So the other number A equal to 23 into 14449 divided by 161. So now this 23 ones are, this goes 7 times, 7 ones are 207. So the other number is 207. Simple problem. Next problem. Explain why 7 into 11 into 13 plus 13 is a composite number. So 7 into 11 into 13 plus 13. 13 is common here. So let us take 13 out. So 7 into 11 plus 1. So this is 13 into 7 to 11 is 77. 77 plus 1, that is 78. Now 78 divided by 2 is 39. Divided by 2 is 13. So this can be done as 13 into 2 into 3 into 13. So this number is product of so many prime numbers. Hence this number is a composite number. Find the largest number that divides 320 and 457, leaving the remainder 5 and 7 respectively. Now the largest number, suppose say x, that divides two numbers is nothing but the HCF of those two numbers. But now here x does not divide 320 and 457. It does not divide perfectly because it leaves remainder 5 and 7. So x divides not 320, x divides 320 minus the remainder 5. So x divides 315. Same way x divides 457 minus 7, that is 450. So there is a largest number which divides both 315 and 450. We need to find out that. So that is what? That is the HCF of 315 and 450. Let us find out the HCF of these two numbers. So 315, let us find the prime factors. 315 prime factors are 3105, 335, so 5 and 7. For 450, you can divide by 2, so you get 225. So if divided by 3, 2175, again you can divide by 3, that gives 25. So it is 5 and 5. So now 315 can be written as 3 into 3 into 5 into 7. 450 can be written as 2 into 3 into 3 into 5 into 5. So the HCF of these two numbers is now 2. Here power of 2 is 1, here nothing. So we won't take 2. Here power of 3 is 2, here power of 3 is 2. So we need to take 3 square. Then here power of 5 is 1, here power of 5 is 2. So we will take the least of the power, that is 5. 7, here it is not there, so we won't take it. So this is 9 into 5, so it is 45. So this is the number 45 that divides into 320 and 457, leaving the remainder 5 and 7 respectively. Three pieces of timber, 42 meter, 49 meter, 63 meter long, have to be divided into planks of equal length. What is the greatest possible length of the plank? Now, how will you know whether we have to find out HCF or LCM? Now here we have to find out the greatest possible length of the plank, but he says that it has to be divided, it has to be cut into pieces. So the length will be surely less than these lengths. So only HCF is smaller than the numbers. LCM is always equal to the largest number or greater than the number. So we have to find out here the HCF. So let us do the prime factorization. So 42 divided by 2 is 21, 3, 7. So now 49 divided by 7 and 63, 21, 3 and 7. So 42 is written as 2 into 3 into 7. 49 can be written as 7 square, 7 to the power 2, and 63, this is 63. 63 can be written as 3 into 3, or 3 to the power 7 into 7. Now therefore HCF. Now HCF is equal to the product of the least power of the prime factors. Here it is 2, 2 is not there anywhere, so we must leave it. 3 is not here, so must not consider. 7, here 7, 7, 7 square, so HCF is 7. So the length of each plank is 7 meters. So if you have the length of the plank as 7 meters, then you will have 6 planks here, 7 planks here, and 9 planks here. Fifth problem. 3 people are running around a circular park and they take 6, 10 and 15 minutes each to complete one round. First one takes 6 minutes, second one takes 10 minutes, last one takes 15 minutes. They start running together from a designated starting point. After what time they meet again at the starting point? Here also we need to find out whether it is LCM or HCF. Now let us take the round circular park. Now this is the park. You have A, B and C. A completes in 6 minutes, B completes in 10 minutes, C completes in 15 minutes. Let us take first C. C completes in 15 minutes. He starts from here, he completes in 15 minutes. That is the round 1. Round 1 he completes in 15 minutes. So by the time C completes 15 minutes, he completes in 6 minutes. So he would have finished here 2 plus rounds. So 2 rounds means 12 minutes. So in 15 minutes, 2.5 actually. 2.5 rounds he would have finished. Now B, when C is back here, B would have completed. So 1.5 round. So now again, C now completes 2 rounds. So he has spent 30 minutes and completes 2 rounds. When he spends 30 minutes and completes 2 rounds, B he completes in 10 minutes, so he completes here. This fellow has done 2 rounds. This fellow completes 3 rounds. Now this finishes 1 round in 6 minutes, so it is 30 minutes. So he completes 5 rounds. So all of them complete full rounds. That is 2, 3, and 5. So they meet at this point. So That is, after 30 minutes, they meet at the starting point. Now we know 30 minutes is the answer. How do we get that? Now 30 is nothing but the LCM of these three. That is, let us find out the LCM. 6 equal to 2 into 3, 10 equal to 2 into 5, 15 equal to 3 into 5. So LCM is nothing but the product of the highest powers of each prime factor. So the highest powers are 2 into 3 into 5. So 6 into 5, it is 30 minutes. This is how we find out the answer for such a problem. So this kind of problems we need to do LCM.